all around you, you can see things that follow a certain pattern. A flower, its petals follow a pattern, right? That's why it's symmetrical. A flight of stairs, it's just a line of bricks that are ascending, but they have the same height, the same width, right? So everything, well, not everything, but most things follow a pattern. In mathematics, when a list of numbers is given to you, and if that list of numbers follows a pattern, right? So each consecutive term is predictable by a certain pattern. That list of numbers is called a progression. We'll be discussing three types of progressions: arithmetic progressions, harmonic progressions, and geometric progressions. And once we've discussed the outline of these three types of progressions, we'll do a couple of practice questions, and I'll also discuss a common error made by students when solving these progressions. Now, what is an arithmetic progression? So basically, it's a sequence of numbers, and since it's a progression, every consecutive number will have a relation to its previous number and its next number. So in an arithmetic progression, the relation is that the difference between two consecutive numbers is always constant. We denote it with D as it is over here. So A2 minus A1, meaning the second number minus the first number, will give you a value, right? For the sequence to be an arithmetic progression, the third number minus the second number, the fourth number minus the third number, the fifth number minus the fourth number, the sixth number minus the fifth number, and so on. All of these differences must be equal. So this is an arithmetic progression, and just to clarify, let's see an example. Say you have a progression of four numbers. The first number is 3, the second number is 6, the third number is 9, and the fourth number is 12. Now you can see where I'm going with this. This A2 minus A1, so the second number minus the first number, is equal to 6 minus 3, which is equal to 3, right? Now A3 minus A2 is also equal to 3. A4 minus A3 is also equal to 3. And since all of these differences between consecutive numbers is equal, this means that this progression is an arithmetic progression. And to find a number at any position in the progression, you can use this formula. So an is equal to a1 plus n minus 1 into d. So n is the position that you're looking at, an is the term at that position, and a1 is the first number in the progression. So say you wanted to find the fifth number, so you wanted to find a5. a5 would be equal to a1 plus 5 minus 1, which is 4, into d. So a1 plus 4d, and d being the common difference. Now, similar to the arithmetic progression, we have the harmonic progression. And all you need to remember is that the harmonic progression is the reciprocal of the arithmetic progression, right? So let's say you have this general form of an harmonic progression, and these are the terms starting from the first term h1, the second term h2, h3, h4, up till hn, n being any number, right? So the nth term in the progression. Now you can write this down like this. Now you remember that in an arithmetic progression, we denoted the terms as a1, a2, a3. And since the harmonic progression is the reciprocal of the arithmetic progression, you can write it down like this, right? So the first term, which was h1, can be written down as 1 over a1, right? And these a1, a2, a3, a4 up till an, these terms are the terms of the equivalent arithmetic progression. So basically, if you just take those denominators and subtract two consecutive denominators from one another, and if they have the same difference till the end of the progression, you can confirm that it is indeed a harmonic progression, right? So again, to find out if a progression is harmonic or not, you will again need to apply the same principles of the arithmetic progression. So let's say you have these terms in the harmonic progression, right? The first term is 1 over 3, the second term is 1 over 6, the third term is 1 over 9, and the fourth term is 1 over 12. And you need to confirm if this is a harmonic progression or not. So again, as we've seen before, take the reciprocal, so you can find its arithmetic progression equivalent values, and now subtract two consecutive terms to see if they have a common difference or not. So a2 minus a1 is 3, a3 minus a2 is 3, a4 minus a3 is 3, and clearly it has a common difference. And since you have confirmed this, this is indeed a harmonic progression, right? All you need to do is this: convert it to an arithmetic progression, see if it has a common difference, and it is indeed a harmonic progression. Now, you remember the formula to find the term at any position of an arithmetic progression. Now, similarly, to find a term at any position in a harmonic progression, you just do this. Take the reciprocal of the previous formula, right? So the term at the nth position of the harmonic progression will be equal to 1 over 1 by h1 plus n minus 1 into the common difference d, right? So say you need to find the fifth term of the harmonic progression. That would be equal to 1 over, and then in the denominator you'll have 1 over the first term of the harmonic progression, because again we're dealing with reciprocals, plus n minus 1 into d. And since we took n as 5, n minus 1 would be 4. And d is the common difference that you'll find by taking the reciprocal of the harmonic progression and subtracting the consecutive terms. Now let's see what a geometric progression is. Now again, remember it's a progression, so each consecutive term will have a relation to one another, right? So again, you can denote the progression with any variables. Let's just use the same ones that we used in the arithmetic progression. So the first term is a1, the second is a2, a3, a4, up till an, which is the term at the nth position, which can be any number, n being the last position. And in case of the geometric progression, the relation between two consecutive terms is that the division of the two consecutive terms will always give you one value. So the second term divided by the first term will have a value, let's say that's r, and the third term divided by the second term will also equal r. The fourth term minus the third term will also equal r. So r here is the common ratio. Now, in case of the arithmetic progression, there was a common difference. In case of a geometric progression, there is a common ratio, right? So to make things clearer, let's say that the geometric progression is of 4 terms, and the 4 terms are 3, 6, 12, and 24. Now you can see where I'm going with this. Now you need to divide two consecutive terms and see if they all yield the same value. So the second term minus the first term, so a2 divided by a1 is equal to 2, because it's 6 divided by 3. Now a3 divided by a2 is 12 divided by 6, which is also 2. a4 divided by a3 is 24 divided by 12, which is also 2. So you can see clearly that the terms in the sequence or the progression all have a common ratio. So this is indeed a geometric progression. And now for the formula. Now if you need to find the term at the nth position, so any position, you can basically use this formula. So an is equal to a1 into r to the power n minus 1. So n, let's say you need to find a5, the fifth term. So n is 5. Now a5 is equal to a1 into the common ratio r to the power n minus 1, which is 4. So a1 into r to the power 4. Now let's solve this question regarding the harmonic and arithmetic progressions. Obviously, once we can solve a harmonic progression, we can solve an arithmetic progression as well by default. So basically, the question states that we have to find the 9th term of this harmonic sequence. So obviously, the first thing that you need to do is to find the equivalent arithmetic progression. And since we all know that the harmonic progression is just the reciprocal of the arithmetic progression, that means that the arithmetic progression of 1 by 3, 1 by 5, and 1 by 7 is 3, 5, and 7. Now, all you need to do is find the common difference, right? The common difference, you can just take any two consecutive terms. So let's take 5 and 3. So 5 minus 3 is equal to 2. And again, 7 minus 5 would also be equal to 2. But again, we just need to find the common difference. And we already know that the first term, which we denote as a1, is 3. Now that we have a1 and d, we can just apply the formula. The formula states that an is equal to a1 plus n minus 1 into d, right? We already found d, right? And we already found a1. Now n is 9 because we need to find the 9th term. So simply a9 is equal to a1 plus 8 into d. a1 was 3 and d was 2. So a9 comes out to be 19. But wait, we were told to find the ninth term of the harmonic progression, which means that you'll have to take the reciprocal of 19, because 19 is the ninth term of the arithmetic progression. So the ninth term of the harmonic progression is 1 by 19. Now let's do a practice question regarding the geometric progression. Now it's a very simple question, but it'll clarify the concept. It says that we have to find the fifth term of the geometric progression, right? And this is the geometric progression, 3, 6, 12, and so forth. Now, we only have 3 terms. We have to find the fifth term. So what we simply need to do is, we first find out what the first term, a1, is, because that will be used in the formula, and that is 3, right? Now we need to find the common ratio. Now, again, let's just take this 6 and this 3, the 2 consecutive terms, divide 6 by 3, you get 2. And if you divide 12 by 6, you also get 2. So again, we just need to find the common ratio, which in this case is 2. And we also have n equal to 5 because we have to find the fifth term. Now that we have a1, r, and n, all we need to do is plug it into the formula, which is an is equal to a1 into r to the power n minus 1, right? a1 was 3, r was 2, and n was 5. So a5 is equal to 3 into 2 raised to the power 4, which is equal to 48. Now let's discuss the most common error made by students when solving progressions, and that has to do with the harmonic progression. Now again, this is the general form of a harmonic progression, h1 being the first term of the harmonic progression, h2 the second term, h3 the third term, up till the last term at the nth position, which is hn. Now, I told you that arithmetic progressions are very similar to harmonic progressions, which is why some students think it's okay to do this. In an arithmetic progression, the difference between consecutive terms is constant. It's a common difference. So, well, if the harmonic progression is the reciprocal of the arithmetic progression, some students think it's okay to just take the difference of the consecutive terms in the harmonic progression and see if there's a common difference. But this is wrong. You see, the reciprocals, if you subtract them, they will not have a common difference. The reciprocals of the arithmetic progression will not have a common difference. You can try this if you want. So, if you take the reciprocals of the terms in the harmonic progression, they will give you equivalent arithmetic progression terms, and those will have a common difference. So h2 minus h1 will not equal to a common difference. 1 by h2 minus 1 by h1 will equal to a common difference, because 1 by h2 is the second term of the equivalent arithmetic progression, and 1 by h1 is also the equivalent term of h1 in the arithmetic progression. So in summary, in an arithmetic progression, to find a term, you use the formula an is equal to a1 plus n minus 1 into d, in which a1 is the first term of the progression and d is the common difference. To find a term in the harmonic progression, you use the formula hn is equal to 1 divided by 1 over h1 plus n minus 1 into d. And to find a term in a geometric progression, you use the formula an is equal to a1 into r to the power n minus 1, in which r is the common ratio. And I hope this video really helped you in understanding all 3 types of progressions very well, and I'll see you in the next one.